3D plotting. Basically, 2D plotting is required two axes and hence only two coordinates. But for 3D, we require three coordinates to represent any point. So let's get the z-axis to plot 3D graph. So for that, we'll close this thing. We'll add z over here. Z is equal to x into sine of x. Instead of this simple plot, we need to write plot 3 for 3D. And we need to provide three coordinates x, y and z. We have provided x label, y label. So we will also provide z label. And let's run this thing. So this is our first simple 3D graph is ready. If you want to title it, so it is first simple 3D plot. Now when you click this rotate 3D button, you can click and rotate this graph. You can change your viewing angle, the perspective from which you are observing this graph. So just hold on left click and drag. You can view this graph from different angles. When I am shifting this graph over here in bottom left corner, you can observe two values, AZ and EI. Right over here right now it is minus 21 and EI is 22. This is basically azimuth and elevation. This azimuth means what direction to face. Basically horizontal movement represented by azimuth, and the second term represents elevation. Elevation means vertical movement, at which height you are observing. Basically, this azimuth and elevation is represented to identify the location of satellite, which is rotating above the earth. But for our 3D graph, it is representing our viewpoint, from which angle and which height and which direction. So basically from direction and angle you are observing this graph, it is represented by this azimuth and elevation. Just close this thing. Now every time when you run the graph, the viewing point will be set to the default point. What if you like to set this graph to a particular viewing point? For example, let us rotate it like this, and this is the angle where we want to view this graph. Let's just rotate it a little more. It looks like V of learning vibes, right? But this is not the appropriate angle. So let's shift it a little bit more, and I think let's keep it up to this point, right? So azimuth is minus 8 and elevation is 41. Remember this thing. I'm closing this thing, running it again, and it is again set to our default point. The default point is something else, right? Minus 3730, but we want to keep it on minus 8 and around 31, right? So close it, and here you should write view minus 8 comma 32, and let's run it. So the graph is set to this viewing point. So whenever you are plotting 3D graph, you want to set your perspective up to certain angle, then you can set those angles from this command. Let's say instead of this minus 8, we want to do it minus 28 and run. So this is minus 28 and the graph looks like this at this angle. So this is important command. Now if you want to change the line width, that you can do it from here. Let's say 3, run. So this is how you can change the line width of the graph. There are still few more styling ads that you can use in plotting this graph, but that we'll see later on. Now there is another graph which is being used by many users in MATLAB. That is scattered graph, which is also being used widely in 3D. So how to plot that 3D scattered graph? Let me show you that thing. For that, we'll just comment it, and over here we'll write and just run. See, this is our scatter graph. If I just comment this view and run, this is the default view. Now let me show you one thing, that this is how we are plotting the scatter graph, but using this plot command. The same plot command, if you want to plot the same scatter graph, how you can plot. For that you need to do some changes in the command. Changes like, we want to plot circles and that would be blue. I think this much is enough, but we need to plot this thing on a separate figure. So let's write figure over here and run. So this is our figure 2 and this is our figure 1. In scatter graph the grid is on and in plot grid is not on. So let's close it and let me turn on the grid. So now the figure 1 represents plot 3 and figure 2 represents the scatter 3. So these both the graph are almost similar. The only difference is in the color. We have made some small changes in the value of x. And now let's run. So now you can see the graph itself is getting animated. See how this graph is animated. And if you want me to explain how I did this, then ask me in comment section below. I'll make video on that topic. One more thing I want to tell you, that you can even export this animation as a video. I'm not joking. You can export this thing as a video. And if you want to learn how we can export this thing, this animation as video, then ask me in comments. I'll make video on that topic. But I need some handful of comments in this comment section of the video so that I can come to know that many people want to watch this video, and I'll definitely make video on that topic. And after this bonus tip, I'm going to show you something else. So now we don't want this thing. So again, we'll comment it. And now I'm going to show you something else. For that, let's bring all these things back. So I'm going to uncomment it. We don't want this scatter graph now. So remove this thing, run. We want a line graph. So this is our old graph which looks like this. But this is just a line plot. It is not the surface plot, right? So to convert this line plot into surface plot, there is another command which is known as surf. Close this thing. Instead of this plot, write surf. But to use this surf command, this z should be a matrix. And to convert this z into matrix, we need to write a small code. And the code is this, the mesh grid. This mesh grid will convert 1D vector into a matrix. A more detailed explanation on mesh grid is available in our next video. We just shift this x to capital X and this y to capital Y. Now just run this thing. Before running, we'll remove this additional values. So this is known as the surface plot.